Okay, what's up? Today I'm going to teach you how to add and subtract radicals. Now, the game changer here is you have addition and subtraction signs inside the expression. Before you didn't have that. Okay, so you just were able to make one radical, multiply the insides, multiply the outsides, or divide. Okay, that's going to be a game changer. Now, on the first part, I'm going to split the lesson kind of up into increments. Underline what's in your square root. First off, you have addition or subtraction, you want to circle it. And what you do is underline the expression under the roots. It's the same. So what you do is make a square root of 6, and you're allowed to then add 10 plus 2. It'd be 12. It's very similar to like taking a 10x plus a 2x. It'd just be 12x, but in this case, we'd have 12 with a square root of 6. Okay, next one here, that's a subtraction sign. Okay, so I look inside, and we have equivalent expressions equal. I can take 8 minus 5, and that's 3. Pretty much a walk in the park at this point, okay? Minus sign. And by the way, if you don't know if something's a negative sign or a minus sign, come ask me. Okay, I'm not the greatest writer in the world. So you got the square root of 5x. And then 3 minus 2 is 1, okay? Okay, so here I have equivalent expressions underneath of x, y, and then I can add the outsides. 3x plus 4x would be 7x. Okay, this time you got a fifth root, but you have equivalent expressions. Okay, you got 3x to the second, and then you can take 17 minus 15, and that's 2. Okay, minus sign, so you're under your radicals, you have y. Okay, and then 8 minus 12 would be negative 4. Okay. Now here you got a problem, okay? It's not a big problem because you're just going to write something. If you have a minus or a plus and what's under the radical are different, totally different, if they don't match up identically like all these problems did, they're different, you write not possible, okay? Okay, why don't you pause the video and do 1 through 5, okay? One of those is a not possible. I'm not going to tell you which one. Do 1 through 5 and then resume it. Okay, now the next one, here's what we go with, okay? Now you're like, oh, that's not possible, but when I have actual numbers instead of variables, instead of letters, I need to try to simplify these radicals. See, like on this example here, you can't really simplify an m and an n, but when they're actual numbers, you can simplify those. So what I do on adding, subtracting, remember the whole end game is to get the same thing under the radical, okay? Now when you multiplied and divided, it didn't matter if they were the same. You just went ahead and did your operations. But now you're going to make a table, and on one side you're going to put 10 radical over 27 and then a 4 radical over 12. Now it's important for you to know which list you're going to look at here. These are seconds if they don't have one. So what I'm going to do is I'm going to drop my factor of 10, okay? And I'm going to attempt to rewrite that in 2 square roots, okay? And I drop my factor of 4, and I attempt to rewrite that into 2 square roots, okay? So 27, not on the list, so I start dividing. I go 27 divided by, okay? And I'd start with 25, didn't work. To go 27 again, divided by 16, didn't work. 27 divided by 9, that works. So I put 9 in the first, 3 in the second. And this actually becomes a number. It becomes 3. Okay? So I now have 10 times 3 times radical 2 over 3. Now we're going to take 10 times 3. That's 30. And then just leave the radical alone. Okay? Now the game's the same here with the 12, okay? 12 divided by 9 doesn't work. If you divide by 4, you get 3. So this becomes 2. So 4 times 2 is 8. Whoops, I'll show my work better. 4 times 2 times radical 2 over 3. And then I can multiply 4 times 2. So that's going to be 8 square root 3. Now rewrite this problem. This has now changed into 30 square root 3. If it's a 2, you don't need to put the little number. Minus, and this one's changed into 8 with a square root of 3. So now I have equivalent expressions under the radical. So I put square root of 3 and I go 30 minus 8, and that would be 22. Okay. Next up, that minus sign again, okay, it's a game changer. It means you're going to make a table because your whole end goal is to get the numbers underneath to be the same, to have identical expressions. So 10 radical 3, 81. And then 8 radical 3, 24. Okay, so now we're on the cubed roots. So 81's not here, so I divide into it. So we'd start with 64, decimal, 81 divided by 27. Okay, that works. So I want to drop the 10 and then write this into 2 separate radicals. Okay, and that would be 27 and 3 in that order too. So that changes into 3 whole. This one does because the cubed root of 27 is 3. So we have 10 times 3 times radical 3 over 3. 10 times 3 is 30, radical 3 over 3. Okay, now the next one, 24 is not a perfect cube, so I divide into it. So 8, drop that, and we got to attempt to make this into 2 roots. Okay, remember 8 in front of that means it's 8 times the radical. 24, I think it's either 8 or bust. Okay, well I can do 1, I guess. Okay, so 8 and 3. And the cube root of 8 morphs into 2. Okay, so I now have 8 times 2 times the cube root of 3. So 8 times 2 is 16, cube root of 3. Now rewrite the expression. This now is 30 cubed root of 3. These are the same expressions. They're equivalent expressions. This one's just been simplified. 16 radical 3 over 3. So, we got matching expressions. Now you want to make sure you label the root with a 3. Now when it's a 2, you don't have to put the label, but with 3, and you put 3 underneath, and 30 minus 16 is 14. Okay? All right, next one. So I have 5 with a radical of 3 and a radical of 12. Okay, so I drop the 5. And now, since they don't have numbers, we're automatically into the second list. Now 3 would start at 1. Well, you can divide 3 by 1. I mean, sure you can. I mean, 3 divided by 1 is 3, so I put 1 from this list and then 3. So square root of 1 is 1. So we have 5 times 1 times the square root of 3. So 5 times 1 is 5. Square root of 3. So really, I really didn't simplify it much, but I followed the process, and let's look at the 12. Now I don't have a factor in front, so I just write the 2 square roots, okay? And then 12, as we saw before, is divisible by 4. Because if I divide 12 by 4, 12 divided by 4 is 3. And this becomes 2. So there's really nothing to multiply, I just have 2 with a radical 2 over 3. Okay, so this one doesn't change. They're 2's, so I'm not going to put the 2's in there if those are 2's. And this now becomes 2 square root 3. Mission accomplished, they're the same, okay? And then 5 plus 2 is 7. Okay, my next one. Something weird's going to happen. You got the cube. Actually, something easy's going to happen. You just got to know how to handle it. Okay, let's look at the cubed root. Well, actually, no, this will be the same. Sorry, I misread that. 54, I'd be on this list here. Okay, so I'd divide. There wouldn't be an outside factor to drop, so it's just this. So 54 divided by 27. Cha-ching. So I have 27 and 2, and that becomes a 3. So I now have 3 with a radical of a degree 3 over 2. 16 isn't on the list, okay, but I see something right away it's going to divide by. So I rewrite that in 2 radicals. Now if I divide by 8, 16 divided by 8 is 2. And then we replace that radical with its whole number equal, which is 2. So we have 2 radical 3 over 2. So this has been simplified into 3 radical 3 over 2. This has been simplified into 2 radical 3 over 2. So mission accomplished. Underneath they're the same, so I have radical 3 over 2, and 3 plus 2 is 5. Okay, then this one here, that needs to be a plus. Sorry, I didn't put the sum symbol there for what you're doing. So again, underneath they're different. Okay, so I have radical 4 over 32, radical 4 over 48. Okay, now I want to rewrite this in 2 radicals. If 32 is not here, okay, so if 32 isn't here, I make the 2 radicals. I start dividing 32, these numbers, 32 by those numbers. So 32 divided by 16 is 2. So you have 16 and 2. 4th root of 16 is 2. Okay, so we have 2 with a radical 4. So rewrite that. Okay, 48 divide into 48 because it's not on the list, and I'm trying to rewrite it into 2 radicals. And 48 divided by 16 is 3, so I have 16 and 3. And of course, radical 4 over 16 equals 2. Okay. All right, now I've simplified as much as I can. Okay. But here's the problem. We still don't have the same number. So now you can label it not possible. Okay, so you try to simplify it first. Okay, now I'm gonna save these for later here. Okay, after you're done with the assignment, we'll look at those. Okay. All right, now let's look at here. Now I have triple radicals. They're not, none of them are the same. So I'm going to make a chart that's 3-sided, okay? Kind of like that. So I put the square root of 75, 4 square root of 18, and then 2 square root of 32. So here, now I'm on the 2 list because there's nothing there. So I look here, and 75 is not here, so I need to rewrite it into 2 separate ones. Don't have an outside factor to drop. So 75 divided by 64 is a decimal. Divided by 49 is a decimal. Divided by 36, decimal. Whoops, 75 divided by 36. 75 divided by 25, cha-ching. Okay, so I have 25 and 3. And that is replaced with 5. So I have 5 with the square root of 3. 18, not on the list, so I'm going to make 2 radicals, but I dropped the 4 down because we're going to have to multiply something by 4. So 18 by 16, no. Divide by 9, yeah, you get 2, okay? So that becomes 3. And then I have 4 times 3 times the square root of 2, which I will need to take 4 times 3, and that would be 12. Okay. Okay, now let's look at this. Okay. 2. Okay, 32 is not here, so I drop the big 2, and I rewrite it in 2 radicals. Okay. 32, I'd start with 25. Decimal. 16, cha-ching, 16 and 2, okay? And then I have 2 times 4 times the square root of 2, and that's going to be 8 with the square root of 2. So now rewrite those. This turned into to 5 with a square root of 3. Minus, and then this turned into 12 with a square root of 2. Plus, this turned into 8 with a square root of 2. Now look under the radicals. Are they all the same? No, they're not. Two of them are the same, so we're going to add those two, okay? Actually, the one that's not the same, the one that's different from the others, just drop him, okay? Then the one that is the same, I'm going to write the square root of 2 down, and I'm going to take negative 12 plus 8, okay? I know it says minus, but a minus acts like a negative, so negative 4. So minus 4 square root of 2, and then that's as far as you can go because they're different. Okay, so again, when I have a threesome like that, the two that are the same, I do that. I drop the square root of 2 and take negative 12 plus 8, okay, and then 5 square root of 3. If I were doing it, the one that's not like the others, I'd just write that down, and then the other two, I'd put that down and do my outside operating. Okay, right here we have another trio of radicals. So you have 3, radical 3 over 16. You got 4, radical 3 over 54. You have just a radical 3, 128. So now I'm on my 3 list, okay? So we'd start with 8. Remember, drop the 3 and then make 2 of them with 3's. 16 divides by 8, it's 2. So I replace this with its equal of 2. So I have 3 times 2 times the radical 3 over 2. And that is 6 radical 3 over 2. Okay, 54 is not here either, so I carry down the 4 and I rewrite it in 2 radicals. So 54 divided by 27, okay, will be 2, okay? So I got 27 and 2. So that becomes 3. Okay, so I got 4 times 3 times radical 3 over 2. So that's 12 with a radical 3 over 2. Okay, and then the next one, 128. It's not here, okay? So I write it in 2 radicals. I don't have that front number to drop. So I'd start at 125. Nice thing about cubes and 4, they spread out, so you don't have to go that far. So I put 64 and 2. So the cube root of 64 is 4, and we now have 4 with a radical 3 over 2. Okay, so this now turns into 6 with a radical 3 over 2 minus, this now has become 12 with a radical 3 over 2. And this now becomes plus, and then 4 with a radical 3 over 2. Now this one's easier than the last one because they're all the same, okay? So if they're all the same, I can just write radical 3 over 2, and then just go from there. 6 minus 12 plus 4. Okay, negative 2. Okay, now you can proceed with your assignment. You can do 6, 7, 8, 9, and 10. Okay, this one they are all going to end up the same, so you'll be good there. One of these 4 is you're going to do your table, but then you're going to realize I can't do it and it's not possible. One of them, okay, one of them. Okay. Now, when you're done with the assignment, if you could resume the video, I want to show you some things on the examples, okay? Work on the assignment now. Okay, hopefully that made sense. Now, again, I'm going to teach you how when there's variables on the inside, okay? They're not equivalent expressions, okay? But when I'm doing this, what I'm going to do, the x squareds are the same. So I'm going to forget about them. I'm just going to put 2 radical 32 and then 3 radical 72. They both be square roots. So is 32 a perfect square root? Nope, not it. So I drop my 2 and rewrite it. So 32 divisible by 25, nope. If you divide by 16, 32 divided by 16 is 2. So 16 and 2. So I replace that with 4. So we now have 2 times 4 times the square root of 2, which is 8 with the square root of 2. Okay. All right, now the 3, 72. Okay, line up your 3. Okay, so 72 divided by 64, nope. Divide by 49, nope. Divide that by 36, there we go, 36 and 2. So replace that with 6, so that's going to be 3 times 6 times the square root of 2, so that's 18 with the square root of 2. Okay, now I'm going to rewrite that, but I'm going to write 8 square root of 2, but I'm going to put x to the second in there, okay, plus 3, or no, not 3 anymore. This is now 18 with the square root of 2, and we put x to the second inside. Now, they are the same, okay? You have equivalent expressions, so you have the square root of 2x to the second. And 8 plus 18 is 26. But here's one thing they're kind of picky about. If you have a variable and a radical, you need to pay attention to what kind of radical that is. It's a 2. Now, you're going to cross that x squared out, and think of it like this. You'd have x times x. You'd put a square root, so that's x. And that would go to the outside then, okay? And we wouldn't have any left on the inside, okay? But there's still that 2 in there. Kind of like you did variables before. Okay, next one. This one's going to be a quick one. Okay, what would happen if I go look, oh, leave the x's out. Okay, remember I forgot that. Leave the x's out, sorry. We'll put them back in when we get over there. 125's here, I'm just going to put 5 down. 27's here, I can just write 3 down. So I'm going to replace that with 5 minus, and I'm going to replace that with 3. Now you still need the radical 3 because there's x to the 6th, okay? But at least they're the same, okay? So I have radical 3, x to the 6th. And then I could take 5 minus 3, which is 2. Now again, with the variables, we think of it like this. There's 6 x's, okay? And I would go 3 at a time. There's x, no left, so I would get rid of that, and x to the second, because there's 2 of them, would go out here. So it'd be just 2x to the second, because the radical's empty. When the radical ends up empty, we don't need it. All right, next one. So you got 4 radical 216 y to the second. Or no, get the y out of there. I keep doing that. And then 3 with the radical 54. So they're radicals of 2. Okay. So I would line up the 4 and line up the 3. And we're not so lucky here. Okay, 216. Have to start dividing, okay? Decimal. 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 I'm going to cheat a little bit, okay? Divide by 36, and that's what we have. So I would rewrite that as 36 times 6. And they're 2's, okay? So that becomes a 6, so I have 4 times 6 times the square root of 6, and that's 24 square root 6. Okay, let's look at this one. So actually, hold on, this problem, no, this will work, okay? So I rewrite that times square root, and 54, I would cheat a little, I'm going to cheat a little bit as a teacher. Decimal, 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 decimal. If I divide it by 9, I finally get a non-decimal. Okay, so I have 9 and 6. So the square root of 9 goes to a 3, and 3 times 3 is 9. Because you got 3 times 3 times the square root of 6. So this has now simplified into 24 square root 6. And this is simplified into 9 square root 6. We're going to put those y to the seconds inside. Okay. Now I do have equivalent expressions underneath. They're the same. 6y to the second. 24 plus 9 is 33. Now let's talk about the y to the second though. Now it's a 2, so that means y times y. I'd put 2 of them, which give me a y. So that y goes out because there's none left. There's none left at the end, and then I just transport that y there, right there, after the 33.